I'm Mike Curie at Kennedy Space Center, and I'm here today with Scott Wilson, Manager of Orion Production Operations for NASA. Scott, thank you for being here.
Oh, thank you.
We are in what is called the ONC Building. Can you tell us what that is?
Yeah, the ONC Building is a building here at Kennedy Space Center, and it's really where all the parts of the Orion spacecraft come together from around the country and around the world. And it's where we put those parts together really to take the vehicle from a piece of metal all the way up to the full spacecraft that you see behind us today. It's a really interesting building. It's got a really rich history. It goes back to the days of Apollo. The Apollo spacecraft were assembled here. The lunar landers, the lunar rovers were integrated and tested here, as well as parts of the space station and the shuttle payloads for many years. So in a lot of ways we've come full circle to going back and starting exploration from this building. So.
Well, a lot of exciting things have been happening, and lately you stacked the crew module on top of the service module. Can you tell us what the crew module and service module are?
Yeah, absolutely. The crew module is a cone-shaped capsule structure in the vehicle behind us, and it's really where the crew lives and works while they're in space. It provides all the life support systems for the crew, provides all the command and control capability that they need to be able to fly the mission. And just as importantly, when the mission's done in space, it's the part of the vehicle that helps to return them to Earth and protects them from the heat of re-entry as we go back through the atmosphere. So it contains the heat shield and the back shells, which are essentially tiles that protect them from the heat, as well as the parachute systems that let us softly return to Earth. So it's a very important part. The service module, as the name implies, provides a lot of the services that you need while you're in space. So it's where we have the main propulsion systems, the main engines. It has the solar arrays that provide the electricity, the large tanks for fuel and oxidizers, as well as the oxygen and systems that we need to support the mission. It's actually jettisoned in flight just prior to re-entry, and so it doesn't participate in that part of the mission.
So in terms of the Orion milestones and schedule, what does it mean to now have stacked the two together?
It's a great question. This is a really big milestone for us. It's been probably over 2.5 years ago we got our first pieces of metal into our factory in New Orleans. And from there we began welding together what we call the pressure vessel, which is the internal part of the vehicle, which really keeps the atmosphere in where the crew lives and works. That piece of metal got here about 2 years ago now into this building, and ever since then we've been putting on all the other systems that make that piece of metal into a full-blown spaceship. It's all the thrusters, the environmental control systems, the electrical systems and avionics and power systems, and the parachutes, and really everything that makes it a spacecraft. So it's been a long time coming. We're really excited that we're finally getting to put the two pieces together, the crew module and the service module, into this configuration, and it really marks the first time those two modules are together in the way they would be in space. So it lets us get into a series of tests now where we test the spacecraft as though it were flying.
So what is next now for Orion, and what else needs to be done before launch?
It's a great question too. So we've stacked the vehicles together. I mentioned we're going to go through about 2 months of testing where we'll test the vehicle together. We have a philosophy that says test like you fly, so we'll actually put the vehicle through simulated flight here, and once it's done here we'll go to another building where we'll fuel the spacecraft, put in all the hazardous fuels and the cooling commodities. We'll go to a third building where we'll put the launch abort system on the top, and the launch abort system is a solid rocket motor or a series of motors that's built in a different building. Gets put on the top of this rocket, and it actually pulls the capsule away in the event of an emergency. So we'll stack that on there and go out to the launch pad and be ready for launch in December.
Okay, so launch is in December, and what exactly will be happening on the flight?
This is our first in-space mission. It's actually the second flight of Orion. We did a flight in White Sands, New Mexico a few years ago to test the launch abort system. This is our first in-space flight, and we'll go up and we'll launch on the Delta IV Heavy, as I mentioned. We'll do 2 orbits of the Earth. One of those is what we call highly elliptical, and so it goes out about 3,600 miles from Earth, which is really the farthest that a human-capable spacecraft has gone since the Apollo days. And we do that because we want to be able to come back at the speeds you would see if you came back from a deep space mission. So we come back in about over 20,000 miles an hour when we hit the atmosphere. Just before we hit it, we'll separate the crew module. We'll go in for re-entry. The heat shield and the thermal protection will protect the capsule down until it gets close to the Earth, and the parachutes will come out, and we'll settle down for a splashdown in the Pacific Ocean about 600 miles southwest of San Diego. And the Navy is working with us to do our recovery there, and we'll return the vehicle here. So it's a pretty exciting time for us.
Very exciting times. Well, Scott, thank you for making time for us, and we look forward to talking to you soon. Scott Wilson, Manager of Orion Production Operations here at Kennedy Space Center in Florida.